Good day, everybody. We've been given this question. We are asked to find the area enclosed by these two figures. So we have to obtain the intersection. Now, what is this? Let me consider y greater than equal to square root of modulus of x positive 3. Now, if I were to square this, I get y squared greater than equal to, the square root goes off, I get x positive 3 modulus. Now, y squared will actually take x positive 3 if x positive 3 is greater than equal to 0. So that means when x is greater than equal to negative 3, that is the understanding. Now, in case if x positive 3 is strictly less than 0, then the value that y squared will take will be negative of x positive 3. Okay, so you have to get this straight. So rewriting, I get y squared greater than equal to x positive 3 when x is greater than equal to negative 3. The other value will be negative. You can either distribute the negative sign inside. I will just retain it as negative of x positive 3. And in this case, x is strictly less than negative 3. Okay? X is strictly less than negative 3. So this is actually a parabola. Two parabolas are there. Now, next we consider 5y less than equal to x positive 9 less than equal to 15. Now what is this? You divide by 5. Y is less than equal to x positive 9 over 5 less than equal to 3. So that means we have a line y is equal to x positive 9 over 5 and y is equal to 3. I take x positive 9 over 5 less than equal to 3. This means x positive 9 less than equal to 15. We move this 9. I get x less than equal to 15 negative 9, which means x less than equal to 6. So we will have to use this and this and draw the graph. So that is what we are going to do. So let me go to the next page and put these things in place. So first we need the two pillars. That's exactly what I'm going to do. I'm going to draw the axis x and y. I have started with y axis, followed up with the x axis. So this is our x axis, this is our the great y. Now y is equal to 3. This is the point which the graph will not, or the line will not, or the line will stop. So 2 and 3. So I will draw this as a dotted line. So this line is moving. Now we got x is less than equal to 6. So this is 1, 2, 3, 4, 5 and 6. So x is equal to 6. Okay, fine. Now we have to draw the two parabolas. Now we have one parabola y squared is equal to x positive 3. Now this is of the form y squared is equal to 4ax, so this will be C-shaped. Now this is inverted C-shaped. Okay, so one is like this, the other is like this. Now what I need to do is I need to find the common point of tangency between these two parabolas. So y squared is equal to x positive 3 and y squared is equal to negative x positive 3. So I'm equating these two. So it's negative of x positive 3. So negative of x positive 3 is equal to x positive 3. Negative x negative 3 is x positive 3. I bring this x to that side, x positive x. I bring this 3 to this side, negative 3 negative 3. This is 2x is equal to negative x, so x is equal to negative 2. 2x is equal to negative 6 and x is equal to negative 6 over 2, which means x is equal to negative 3. So at negative 3 there is a point of intersection. So if I were to take this as negative 1, negative 2, negative 3, so the two graphs are actually hitting this point. Okay, now the most important thing is I need to know where the intersection takes place for y squared is equal to x positive 3. So I need to find the intersection of y squared is equal to x positive 3 with the line y is equal to x positive 9 over 5 and y squared is equal to negative of x positive 3 with y is equal to x positive 9 over 5. So these two intersections, if I get these two intersections, then I would be in a better position to draw the graph. Okay, so let me have this in one corner, excuse me, and move it up, or I would say find that thing out. So first I'm going to find the intersection of y is equal to x positive 9 over 5 with y squared is equal to negative of x positive 3. So if I were to equate these two, I get x positive 9 over 5 the whole squared is equal to negative of x positive 3. So this is going to be x squared positive 18x positive 81 is equal to negative 25 times x positive 3, negative 25x negative 75, and you have x squared positive 18x positive 81. Now you move this, you get x squared positive 18x positive 25x positive 81 positive 75 is equal to 0. X squared, this is going to give you 13143x. It's going to be 156 is equal to 0. Okay, now if you are allowed to use calculators, you can use calculators, but I am working under the assumption that we do not have calculators. Okay, so a is equal to 1, b is equal to 43, and c is equal to 156. X is equal to negative b plus or minus root of b squared negative 4ac divided by 2 times a. So this is negative 43 plus or minus root of 43 squared negative 4 times a times 156 divided by 2 times of a. Now 43, 43, 3 3s are 9, 4 3s are 12, 4 3s are 12, 1, 16, 17, 9, 4, 8, 1, 1849. Negative 156 multiplied with 4, 20, 24, 2, 22, 4, 1s are 4, 5, 6, 624. So from 1849 you subtract 624. Okay, plus or minus negative 43 divided by 2. So 6 to 4 goes off, so there's going to be 5 and 2, and from 18 I have to 1 2 2 5, right? This is what we've got. Now the question is, we will have to find the square root of 1225. So what is 25 25? First, the thing is that we will have to reduce these component. So if I were to reduce by 5, 5 times 2 is 10, 5 fours are 20 and 5. So 5 times 2, 4, 5, and then again I reduce by 5. So what do I get? 5 into 5 fours are 20 and 9, right? So I have a 5 squared here and 49, which is 5 squared and 7 squared. So negative 43 plus or minus root of 5 squared and 7 squared divided by 2. This is negative 43 root of 5 into 7 divided by 2. So from 43 I take away 35, positive 35. So what do I get? I get 8 there, negative 8. So negative 8 over 2, which is negative 4. Have this point x is equal to negative 4 and move to the next. We find the point of intersection between y is equal to x positive 9 over 5 with the y squared is equal to x positive 3. Okay, so that is our objective. So what I'm going to do, I'm going to substitute this over here. So I got x positive 9 over 5, the whole squared is equal to x positive 3. X squared positive 18x positive 81 is equal to 25 times x positive 3. Is x squared positive 18x positive 81 negative 25x negative 75 is equal to 0. Okay, so you add these two, you get x squared negative 7x and 81. From 81 you take away 75, you get 6, right? So it's going to be positive 6 is equal to 0. So a is equal to 1, b is equal to negative 7 and c is equal to 6. So x is equal to negative b plus or minus root of b squared negative 4ac divided by 2 times a, which is negative negative 7 plus or minus 49 negative 4 times a times 6 divided by 2 times 1. So 7 plus or minus root of 49 minus 24 divided by 2. So from 49 you take away 24, you get 5 and 2, 25. So 7 root 25 divided by 2, which means 7 positive 5 divided by 2, which means 12 over 2, which is 6. And then 7 negative 5 over 2, which is going to be 2 over 2, which is equal to 1. So I have x to be equal to 1 and x to be equal to 6. Now we cannot take this, okay, this is out of range, but x is equal to 1 is the point that we need. So what we got x is equal to 1 for the intersection of the line y is equal to x positive 9 over 5 with the parabola y squared is equal to x positive 3, and x is equal to negative, where is the other point, x is equal to negative 4 with the other parabola. What is the other parabola? Y squared is equal to negative of x positive 3. So we will have to graph these two things. So let me go up over here. Now x is equal to negative 4. There is the hit there, and we will have to have the other point. X is equal to 1 is the other point. X is equal to 1. So this is the other point. So now the question is, the two parabolas are at tangents at x is equal to -3. So this is the point, and the line cannot move, or I would say the line cannot hit further than this. Okay, so we have to watch that also. So the graph is going to be an approximation. So I will draw one C like this, and you have the other C hitting like this, right? And it is going up. Actually, I should not have mentioned these points, okay, because we exactly do not know the point where the graph is hitting the y-axis, right? X is equal to 0, so we will have to locate that point, but that point is not required, right? So we will just stretch the graph. So approximately it will be hitting, it will be going like this. Okay, that's an approximate hit, right? And then it moves like this. So the line is hitting here at one point, and it is hitting here at the other point. Okay, so we will have to connect these 2 points. Okay, that's an approximate hit. So this is x is equal to -3, x is equal to -4, and x is equal to 1. So these are the 3 points. Now this is the required area. We will have to get this area. So the question is, what is the formula we will use? We will use area under the curve formula. Okay, straightforward. So having given you this figure, let me draft the required area formula. So from the line, required area, okay, so this is going to be -4 to -3. From the line is x positive 9 over 5 minus this part of the curve, that is going to be root of negative of x positive 3 times the dx. So this is one region, followed by the next region, that is so we have reached here to this point. So from here we have to stretch. So this is going to be -3 to 1, and also we need to have the line. From the line we remove the curve x positive 3. So this is going to be the required region. So I'm going to say A1 is equal to -4 to -3 x positive 9 over 5 negative root of negative of x positive 3 times the dx, and A2 is -3 to 1 x positive 9 over 5 negative root of x positive 3, okay, times the dx. Right, so we need to evaluate this. So let me go to a new page and start the evaluation. So we will use this space here. So A1 is -4 to -3 x positive 9 over 5. This is one part, followed by -4 to -3 root of negative of x positive 3 times the dx. So what I'm going to do is, this is straightforward integration. So this is going to be, if I were to take, say 1 over 5 what, this is negative 4 to negative 3 x dx, positive negative 4 to negative 3, 9 times dx. Okay, and for this part we will have to make a substitution. Let x positive 3 or negative of x positive 3 be equal to some u. So this is going to be negative dx is equal to du. So dx is, I can literally push the negative sign inside, right? But anyway, let me just take it as a negative du. So when x is negative 4, what happens? Negative 4 plus 3 is equal to u. So this is going to be negative 1. So u is going to be positive 1. So the limits when x is equal to negative 4, u is positive 1. When x is negative 3, u is 0. Right? U is equal to 0. And this is going to be square root of negative of x positive 3. That's going to be root of u. And my dx has got a negative u. So this is going to become positive and du with this substitution. So if I were to apply or integrate, this is going to be x squared over 2. The limits are negative 4 to negative 3. And positive 9 times x, the limits are negative 4 to negative 3. And this is going to be u raised to the power of 3 over 2 divided by 3 over 2. The limits are 1 to 0. Okay, so this is going to be 1 over 5. I substitute the upper limit. That's going to be 9 over 2 negative. I substitute the lower limit, 16 over 2, followed by, I substitute the upper limit followed by the lower limit, negative of negative 4. That's going to be positive 4. Now this is followed by upper limit 0, and the lower limit will carry a negative sign. So lower limit is going to be 2 over 3 of 1 with a negative sign. So this is going to be our required value. So 1 over 5, I take 2 out, you get, this is negative 7 over 2, and this is going to be positive 9, and you have a negative 2 over 3. So I take the LCM. LCM is 18 negative 7 divided by 2, negative 2 over 3, which is 1 over 5. So this is going to give me 11, right? Negative 11 over, it's going to be positive 11 over 2, right? Positive 11 over 2, and you have to take away 2 over 3 out. Okay, so this is how it looks. So this is going to be 11 over 10, negative 2 over 3. I take the LCM as 30. You have 33 negative 20, which is going to give me 13 over 30. So this is the value, 13 over 30. Next we will have to get A2. So this is 13 over 30. And A2 is, consider negative 3 to 1 x positive 9 over 5, negative root of x positive 3 times dx. So I can rewrite this as negative 3 over 1 x positive 9 over 5 times dx, negative integral negative 3 to 1 root of x positive 3 times dx. So this is going to be 1 over 5 integral negative 3 to 1 x times the dx positive 9 times negative 3 to 1 times dx negative integral negative 3 to 1 root of x positive 3 times dx. Now I take x positive 3 is equal to u. So dx is equal to du. When x is negative 3, u is equal to 0. When x is equal to 1, u is equal to 4. So this is going to be 0 to 4 square root of u. Dx is du. So 1 over 2. So it's going to be u raised to the power of 3 over 2 divided by 3 over 2. I'm going to write as 2 over 3. The limits are 0 to 4. So negative sign. So you substitute the upper limit. I can write this as negative 2 over 3. I can write it as 4 raised to the power of 1 over 2. That entire component is raised to the power of 3. Because you have 4 raised to the power of 3 over 2. So this is going to give me 2 over 3. 2 raised to the power of 3 is going to be 8 there. Okay. So for this part is 1 over 5. I get x squared over 2 negative 3 to 1 followed by 9 times of x negative 3 to 1. Okay, so this is equal to 1 over 5. Upper limit is 1, so it's 1 over 2 minus lower limit is going to be 9 over 2 followed by 1 negative of negative 3. It's going to be positive 3. So this is what we have got. Okay, so this is equal to 1 over 5. 1 negative 9. That's going to be negative 8 over 2. This is 9 of 4. Right? So this is equal to 1 over 5. Negative 4 positive 36. 9 4s are 9 4s are 36. So this is going to give me 32 over 5 followed by 16 over 3. So the LCM is 15. So 3 to the 6, 9. 5 times 6 is 33 and 80. So this gives me 16 over 15. Okay. So this is 16 over 15. So now area is equal to 13 over 30 added with 16 over 15. So what do I get there? So this is equal to 30. So 13 positive 32. Right. So this is equal to 45 over 30. 5 divides here 9 times, 5 divides here 6 times. 3 divides here 3 times, 3 divides here 2 times. So the required area is 3 over 2 square units. Okay, so this is the solution for this beautiful question. Now I know I have done this question very elaborately. That is to ensure that there is a complete scaffolding of this question. But what you will have to do is you will have to practice this and increase your efficiency, and that is obtained only by practice. So thank you everybody. Please like, share and subscribe.